17. Here first I would like to discuss about conditional PMF. Then I will talk about in detail about how to find joint PMF. So I may go first joint PMF. After that, conditional PMF would come, but I'm just going taking a reverse path because we are having enough idea about conditional probability. That's why first I will discuss about conditional probability mass function. Then I will talk about joint probability mass function. So coming to first part of this lecture, that conditional probability mass function. In last class, I had already introduced what is conditional probability mass function. That means you are having an experiment, and in that experiment, somehow some partial you come to know some partial information. Based on that partial information, suppose that one is C. So this is talking about partial information about that particular random experiment. So with respect to this partial information, now you have to define a new probability mass function. So initially you are having a random variable x in that random experiment. So with respect to that, always that random variable, always you define probability mass function that we denote it by px, a small p x, x suffix x it denote it here corresponding random variable. Now once you are having this scenario, this one is the second scenario where you have already having some partial information about the random experiment. So due to that, based on this information C, do we see any change in the probability mass function? Yeah, definitely there would be change. So we will have a new probability mass function that we will define it probability mass function, the px x given C. So it is defined in terms of conditional probability that it is saying that probability that joint probability of x equal to x is taking value small x and C is also happening intersection. This joint probability divided by probability of C. So because your new sample space would be now C because you are having information about C. That's why it is directly coming from the definition of conditional probability. So that is the new way to define conditional probability mass function. So here I had already explained all this. So in many situations, we are having some partial information about either random experiment or random variable. So it is giving a new way to define a new probability mass function. So here what we are interested in how this information would like to change the probability mass function of x, and the probability mass function is defined like this way. So here you can see, so these things we had already discussed in detail. So probability mass function for x given C is already given, we have already seen C. So it would be defined by probability that x is equal to x given C. So directly it can be defined through this definition of probability, conditional probability. It's saying that joint probability of x equal to x and C divided by probability of C. And further, if you try to look into uh, domain, sample space as a domain, so you can write like in term of event x, capital X equal to x can be written as like this way, intersection C. So this is the definition of conditional probability mass function for given C, a given information C. Here I would like to take one example, then I will go further to discuss in detail. So one example here I have taken what here you will see that there would be few information with respect to one information, what would be conditional probability mass function, with respect to other information, what would be conditional probability mass function. So those things we will solve it here. So this problem is related with wall clock. So just try to visualize a clock. So how many if you take a clock, so how many uh, okay, in a clock, what you observe? What are the things that you observe in a clock? How many needle you observe in a clock? One needle with respect to second, another needle with respect to minute, another needle with respect to hour. So there you will observe three kind of needles. So basically, if you go second is a very elementary kind of time. So just for significant value, people generally taking two two needle more importantly. One is minute, another one is hour. So you can observe that this time we are calling it either 0 or 12, 12 am or 0. So generally call it 0. Then here you will so this would be what, it would be 3. Then in between 0 and 3 what will come, it will come 1 hour. So our needle, it either it will stop at 0 or it will stop at 1 or it will stop at 2 or it will stop at 3. Okay, so like this way you will keep on moving, and this here hour, this would be 6 hour, this would be 9. So these are the stopping point of hour needle. And further, if you go subdivision of hour in term of minute, then between here you can observe it is taking 5 minutes here, from here to 5 minutes, from here to here 5 minutes. That means from journey from here to here it would be 15 minutes. So here you can take it like this way: 0 minute, 1 minute, 2 minute, 3 minute, 4 minute, or 5 minute, like this way. It will come like this way. So minute will stop like this way. It will move like this way: 1 minute, 2 minutes, 3 minute, 4 minute, not 5 minute, like this way. So if you are counting minute, then if you are your minute needle is here, then you simply it will say that there it measured 15 minutes. But if your hour needle is here 3, then it will measure, it will say that 3 hour, 3 o'clock or 3 hour. So that is the scenario of wall clock. Okay, so here problem is coming like this way: the minute hand or needle, you can say that the minute hand in a clock is spun, and outcome omega is the minute where hand comes to rest. So if minute hand or needle is moving and it is going to stop here at 2, that means how much minute it travel 10 minutes. So if suppose minute needle come to a stop here at 3, what does it mean? That means minute needle travel 15 minutes. So that is the random experiment. Okay, that is the random experiment, that uh, uh, minute needle is moving around. And when where it come to rest, that we note down that at that point we total count we note down, and it is giving a measure of minute. Okay, now let here we introduce x is a random variable that is talking about hour, where our hand comes to rest, our hand come to rest. So where our hand will, if suppose our hand is, it is rest at this point 1, that means 1 hour, it measure 1 hour. Then we have to find the pmm of x, we have to find the protein mass function of x. This one is the first question. Second question, we have to find the conditional protein mass function of x given b. What is b? B is talking about first 4 hours. So what are the first 4 hours? 1, 2, 3, 4. These are the first 4 hours. So that would be, that means b means 1 hour, first hour, second hour, 3 o'clock, and 4. So these would come. And second, third problem is that we have to find the conditional PMF of x given d. D is talking about outcome, where this value is taking between not 0 here, it is taking value 1 to 11. So it, this omega outcome, it is dealing with minute. So that means d is nothing, just it is counting a stopping position of minute hand at which lies between 1 to 11. That means we don't have to include 1, we have to exclude 1. That means here d will take value from 2, 3, 4, 5, 6, 7, likewise up to 11. It will go up to, d will take value up to 11. So here we have to find two things here. We have to find protein mass function. Three things we have to find. First, we have to find what is the protein mass function of a stopping our element. So that means protein mass function of x. It is, this one is the simplest job. Next, we have to find protein mass function of x given b. Protein mass function of x given b. This is second question. Okay. Third question, we have to find protein mass function of x given d. These things we have to find. Three things here we have to find. So here conditional kind of approach is coming. If you have anyone is having any issue in understanding the problem, then let me know. Otherwise, I'm going to find this protein mass function, because it is very much essential to understand the problem. If you understand the problem, then you can talk about solution. Okay. If there is no question, I'm going forward. So suppose we assume that hand is equally likely to rest at any of the minute. That minute hand is equally likely to rest at any of the minute in the range ranging from 1 to 60. You know that when minute hand is spinning, then that minute hand can stop anywhere it depends. So stopping at one, stopping at here, anywhere equally likely. So that's way probability of that omega is taking value k. That means one particular minute, a particular 1 minute, 2 minute, or 15 minute, or something like any a single minute. Then the probability of that would be 1 by 16, because that minute hand can stop anywhere within 60 minutes. So in 1 hour total journey is 60 minutes. In 1 hour there would be 60 minutes. So that's a minute hand can stop anywhere. So stopping at any minute point would be equally likely. So that's the probability that omega is taking value a particular minute would be 1 by 16. So equally likely event for any k from the sample space omega that contains value from 1 to 60. Now this one is directly coming from random experiment. Next we are having random variable x that is talking about our hand, our hand which stop either one or two or three or four or five. So if you can say that this either 0, or you can say that 12. So both are equivalent here, 12 o'clock. So either 0 or 12 o'clock. So both are visible. So our hand, it will take value from 1 to 12. So our hand may stop at 1 or 2 or 3 or 4. Again, if you try to visualize that, the stopping of our hand at any hour point would be equally likely. Equally likely. That's why probability mass function of x is just very simple. It is taking 1 by 12 for each j from the sample space. Each j for each j 1 by 12. So this is your first question, is solution of first question, that what is the probability mass function of x. So you got the solution that. Now next question we have to find that in order to find that we need to know what is b, and we need to know what is d. So b is what it is talking about, stopping first 4 hours. So first 4 hour, what are those? Those are first hour, 1 o'clock, 2 o'clock, 3 o'clock, and 4 o'clock. So this is our B event. And what is D? D is talking about minute which take value between 1 to 11. So B I have already D I have already described. This one is D. So first question we will try to find it out. What is the protein mass function of x given b? Protein mass function of x given b, it would be 1 by 4 if j equal to 1, 2, 3, 4, 5. Otherwise, it will take 0. So who would like to comment over how it is coming? Who would like to comment over this? Shirsagar, how probability of x given b is 1 by 4? When x is coming from taking value from any of 1, 2, 3, 4, in that case. Are you getting the meaning of that? Sagar, are you listening me? So did you get the meaning of that? I asked that probability of x given b is 1 by 4 when x is taking value from 1, 2, 3, 4. And if x is other than 1, 2, 3, 4, then the probability mass function value is taking 0. Are you able to see the slide? I am talking about this question. How it is coming like this? If you understand conditional probability in a better way, then easily you can answer this question. It is all about finding probability, conditional probability. So just if you face any problem, no worry, it is a starting page. So what you do, take j equal to 1. 1. That means individually try to calculate probability of x, that probability mass function for j equal to or x equal to 1 given b, you are going to calculate. So how you will calculate this? So it is all about what? Just write down. It is write down like this way. It is saying that it is defined by probability that x is taking value 1 given b. So this picture might be clear to you. Now this one is what? This one is a conditional probability. So it is a conditional probability. So how we define conditional probability? We are defining it like this way: joint probability of x equal to 1 and b divided by probability of b. So I had already mentioned that if you are willing to calculate conditional probability, you can calculate in two different perspectives. So Chirsagar, are you getting now? Are you able to see the value of this uh, probability mass function, conditional probability mass function? Are you able to see this one? So if you are able to see this one, just calculate this probability. What would be value of this probability? What would be value of this probability? Hello, are you listening me? Okay, Prashant, you answer. I think Prashant, Prashant Sharma, I'm asking question from you. What will be the probability of that last ratio what I had given? What would be that conditional probability? Prashant, are you listening me or not? No. Okay, Aditi, would you like to answer? What would be the probability of last ratio? What would be probability of last ratio that I had already defined? I'm talking about this ratio. What is this probability? This ratio. How you can calculate probability of this one? So it is all about conditional probability. Whether you know answer or not, just try to answer it. Whether it is right or wrong, I won't say anything. Then I will talk. I will give answer. What would be answer there? Anything? Anyone who would like to calculate this probability? That will probability of x equal to 1, joint probability of x equal to 1 and b divided by probability of b. Who will calculate this ratio? This ratio. Anyone would like to give answer? No. Yes. Very nice. One answer. Another answer. Just you are in the right track. Another answer. One thing I always used to say that when you are going to solve problem from conditional probability, what you do, forget about your original sample space. Whatever information, partial information is given to you, consider that as a new sample space, and from there try to derive conditional. So from their perspective, what would be answer? Because that time you don't need much calculation. You don't need to do any kind of calculation. So from there, what would be answer? Just B is given now. B is what? B is containing 1, 2, 3, 4. This one is this given partial information in which how many times x equal to 1 is coming? How many times it is coming? Tell me. How many times x equal to 1 is happening within P? Or simply you can say that when you are saying that this joint property, how much time x equal to 1 is happening in B? What is the intersection of x equal to 1 and B? What is the intersection? Just see it. It is very simple. Intersection is simple. This is the only intersection now. Only one intersection you observe. So it would be 1 by 4. Simple answer is 1 by 4. How many elements you observe in B? 4. So answer would be 1 by 4. That means conditional probability, conditional mass function for z equal to x equal to 1 or j equal to 1. Simply you can say that conditional mass function for x equal to 1, it is taking value 1 by 4. Similarly, if you I'm asking find the conditional mass function for x equal to 2 given B. What would be answer? Given, so I am just writing this one in the term of conditional probability. So it will talk about that probability that it is joint probability that x is taking value 2 and B. Joint probability of x equal to 2 and B divided by probability of B. So what would be this probability? This ratio? What would be this ratio? It is very simple. In the similar fashion, what I had calculated for x equal to 1. In that similar fashion, calculate for x equal to 2. Here I have taken x equal to 2. How you can calculate this conditional probability? How you can calculate? Sriram, what is answer? Very simple question I have given to you. Sriram Shiva Ganesh, I am asking from you. What is answer of that for x equal to 2? It is very simple. Just look into B. How much x equal to 2 you observe in B? There is only one. This one is only this one. No? Answer would be 1 by 4. Similarly, if you take x equal to 3, answer would be 1 by 4. If you take x equal to 4, answer would be 1 by 4. So that's why I have taken J notation for integer. So J notation I have taken it. So protein mass function of x given B, it is taking 1 by 4 when x is any of 1, 2, 3, 4. Otherwise, it is 0. So one problem is already over. We are going to calculate the second kind of conditional mass function. Conditional probability mass function. That one it is talking about probability of x given D. So here directly I have written answer, but it is already. I will go for fresh slide. Just I will solve it here. Take it. What is D? D is talking about minute between 1 to 11 up to 11. That means here it is talking about omega such that omega is it lies between 1 strictly greater than 1 and less than equal to 1. It is talking about omega is talking about outcome, omega is talking about minute, stopping of minute. So it is taking total 10 value. Those are 2, 3, 4, 5, 6, 7, 8. I have taken this question because everyone might have definitely one wall clock in your reading room. So that's why this question I have taken. 9, 10, 11. So in total, you observe how many minutes? You observe total 11 quantity in D. So these are the quantity. Okay. Now coming to say that X is talking about hours. So hours, where hours and a stop. X is talking about at where hours and stops. This was the random variable. So it can stop either 1 or 2 or 3 or 4 or 5 up to 12. Hours had only and a stop and a stop. Stopping point. Hour had a stopping point. You can say that stopping point. Okay. So from there we need to calculate conditional probability mass function x given d. What would be answer? Tell me what would be answer. What are the scenario? X is taking value 1. So this is your clock. I will again draw here wall clock. This is the wall clock. This is your 0 or 12 o'clock. 0 or 12 o'clock. You can say that. This is your 3 o'clock. This is your 6 o'clock. This is 9 o'clock. And this one is 1 o'clock. This one is 2 o'clock. Any question? Any question here? If you have any question, and you can observe that this one is first 5 minutes, this one is second 5 minutes, this one is third 5 minutes, like this way. Okay, now coming to find this conditional probability, how you will calculate. So suppose x is taking hour. So suppose x equal to 1. Given this d, x can't take 0 value. So we will not talk about. Suppose x equal to 1. Then what would be this conditional probability? That means what would be probability of x? This would be x equal to 1 and d given t divided by probability of d. What would be this? Who would calculate this? Probability, this ratio, probability that x equal to 1 and d, this joint probability divided by probability of d. So who would calculate? Don't go to calculate probability of d and then probability this joint probability. Actually calculate. You are having information of d. D you have already seen. That means you have seen this minute. This minute you have already seen. Then if you have already seen, how you can calculate? Just you try to see in how many way x equal to 1 is happening in d. In how many way? So when you have already seen this d is taking minute 2 3 4 5 6 7 8 9 10 11, and 1 is happening here, x equal to 1 is happening here, that happening here. That means x equal to 1, before x equal to uh, coming at x equal to 1, d will happens, it will consider this value 2 3 4 5. That means 4 number of minute might have already a stop in minute hand, might have already a stop in total of 10 minutes. So this probability would be 4 by 10. This would be when x equal to 1, probability would be 4 by 10. Now someone say that when x equal to 2, what would be probability? This conditional probability mass function. Just write it in the similar fashion. That means this conditional probability mass function for x equal to 2, it will define as the ratio of this joint probability x equal to 2 and d divided by probability of d. So calculate this one. So what is answer of this one? x equal to 2. This is x equal to 2. Our hand clock, our hand it will stop here, x equal to 2. So what is this probability? How you have already seen x equal to 1 probability of that one. Now you are talking about probability of x equal to 2. So for this probability, so how you can calculate this one? What are the minute hand x in within in the process of happening x equal to 2? What are the minute hand from D will come? Which minute hand will come? Minute hand a stopping point will come. Anyone would like to answer? No answer. Are you getting the solution process or not? Okay, Hemant Reddy, you try to answer. Okay, he ran away. Sarang, Sarang, would you like to calculate? Yes. Would you like to calculate this probability for x equal to 2? Just okay. I'm talking about this. So here x equal to 2. That means our hand stopped at x equal to 2. Then how can you calculate this conditional probability? No, just you are right, but think more because you have already seen x equal to 1 within t, x equal to 1 within t. In that perspective, I will talk. Now, here, this second case is talking about x equal to 2 within t. So, in that process, you have to travel from 6, 7, 8, 9, 10. Then you will reach at x equal to 2. So, that means how many minute hand you observe? A stopping activity of minute hand 5 times 6, 7, 8, 9, 10. So 5 times. So it would be 5 within t. You will observe minute hand will stop 5 times. In within t, how many times minute hand is stopping? 10 times. So probability, this probability would be 5 by 10. Is it clear? Is it clear or not? Okay, very fine, very fine. So this one is very practical problem. You may have that wall clock at your reading room. You can observe that and calculate the probability. Now, next scenario I am talking about when your hour hand is stopping at 3. What is probability? That means I am simplifying this probability. I am writing in terms of just conditional probability. I am not writing in terms of probability mass function. I am writing in terms of conditional probability. So it is saying that x is taking value 3 in d. When d is in the process, when you in d means when you are having information about d. X equal to 3 when you are having information about d. This one is the joint probability divided by probability of d. So what would be this value? X equal to 3, x is talking about stopping at our hand. So this one is x equal to 3. So if you x equal to 3, so x equal to 3, do you see anything common in d? While happening x equal to c, do you see anything common in d? Yes. What you will, so in order to reach x equal to 3, definitely 11 we observe common. The minute hand definitely might have a stop at 11 in order to reach x equal to 3. Our hand x equal to 3. So that's way, and we don't observe other kind of minute stopping hand at d in d. We don't see. So that's why this probability would be 1 by 10. Would be 1 by 10 when x equal to 3. If x equal to 4, we don't see any common thing with d. That means d is unable to say anything about happening of x. When x equal to 4, x equal to 5. So for other cases, it is 0. It is 0 otherwise. When x equal to 2, 3, 4, 1, 2, 3, then you observe positive value of conditional probability. Otherwise, you observe 0 probability. That means impossible event. So this is the conditional probability mass function for given D. So one question is already over. If you have any question here, you can ask. Otherwise, I am going to discuss another question. That one is dealing with residual waiting time. Okay, no question. I am going forward. I need to delete all this. Always go to basic concept of elementary probability. If you are facing any issue, then always you will able to calculate things very nice way. Observe things. My only suggestion would be that if you want to learn mathematics really in a very constructive way, then always observe things. You have to be very good observer. If you are very good observer, then things would be very easy for you in your understanding mathematics. So it is all about observation. Observe clearly, then apply mathematical concept in a very proper way, and things would be easier to you. Okay. Second question is talking about x. It is a discrete random variable with PMM. Okay. Before going to second question, I will discuss about further conditional probability mass function, where the given partial information is not just a set. It happens to be some kind of interval or something like that. It is not just a specific set. It is also, that means simply I would like to say that the given information C is not just a set. It is actually defined in terms of random variable as well. Like one scenario is that C is defined that C is taking random variable is taking value greater than 10. X is taking value greater than 10. That one is one kind of given information. One kind of given information that random variable is taking value greater than 10. Another information is that random variable, that a specific random variable is taking value from a specific interval AB. So those are given information. Based on that, you have to find what is the conditional probability mass function. Okay, that we have to find. So how we define it? Again, if you are willing to define conditional probability mass function, so again, I always used to say that first convert this one in the term of probability, that x is taking value xk given c, and c is what? C is some kind of event, some kind of, whether it is given with respect to random variable or it may be given with respect to something else. Okay, some kind of outcome. Okay, so you first write this now. This one is here. It is a function, conditional probability mass function. Once you are converting in this one is talking about just probability. That means elementary probability. It is a conditional probability. So convert this conditional probability. Go to definition of conditional probability. It is saying that it is ratio of joint probability of x equal to xk and c divided by probability of c. And if suppose just observe binary situation, either xk would be within c or k would be not in C. Okay, in that case, what is happening? If xk is in C, then this joint probability is nothing just probability mass function, below probability mass function at point xk. If xk is not in C, it would be 0. There would be no intersection. So no intersection means always impossible event happens. That if you try to calculate no intersection means intersection would be phi and probability of phi is always 0. So in that case, you observe this kind of situation. Okay. This is an interesting approach to define conditional probability mass function. When C may be anything, not just an event, it may be defined in terms of random. I am taking one example. Consider X be the time required to transmit a message, where X is a uniform random variable with this range. Uniform random variable, that means when you are tossing a rolling a dice, then getting one is 1 by 6, getting 2 is 1 by 6, getting 3 is 1 by 3. That means all event, all outcome are equally likely. All outcome are equally likely. That means here uniform, simply it will say that what is the probability mass function of uniform distribution. It will say that it will take same probability for each value of x. So if you take x anything from the value of this range of the random variable, so it will take uniform probability. It would be 1 by L. How many number you observe? L number. So that's why every value of random variable is having same probability, equilikely probability, uniformly distributed. It is uniformly distributed. So probability mass function of this random variable is given by 1 by L for each x. For each x belongs to range of the random sigma. This is the scenario of uniform random variable. Now question is coming that suppose that a message has already been transmitted from m times time unit, from m time unit. So that means this is the partial given information. C is saying that message has been transmitted for m time. M time till m time message has been transmitted. That means find the probability that remaining transmission time is z times unit. So you know about C. So C, that means is like this way, x greater than C. Okay, then you have to find the probability that J, which is definitely up to C. You have already seen that message has been already transmitted up to C. There is no randomness. Everything is already happened. So after something happening after m, that we will call it m plus j. M plus j, which up to m we have already seen. So m plus 1, m plus j would be greater than m plus 1, and it will go up to l. Last entry is z, so sorry, l, so it will go up to l. So we have to find here conditional probability that m plus j given c. So again we will talk about that probability that x equal to j divided by probability of C. This is probability of C. So x equal to j intersection C also you can take it, but intersection C also you can take it. X equal to j, that will fall again in C. So what is the probability of x equal to j? It would be 1 by L because due to equivalently event, due to this definition, and probability of x is taking value greater than m, that would be L minus m divided by L. Just cancel this and you will get final answer. This is the answer. 1 by L. It is a very simple kind of question. It is already 45 minutes. Regarding attendance, you put your roll number there in comment box. Next thing I will discuss in next class.